Hello viewers, welcome back to my channel Learn with Ravi. In my previous concept, we have seen the topic of percentages. We have learned the basics, we have done some basic models, and this video will help you out in learning more models. So let's get started. In this concept, we deal with a area of the form P into Q is equal to R. In a given problem, you'll be given some entities which are of the form P times Q is R, and it results in a area where if P gets modified, Q gets modified, then obviously R will get modified, isn't it? The examples of P times Q is R is price of an object into consumption expenditure, price of an object into sales is revenue, length into breadth is area. So if P gets modified by X percentage and Q gets modified by Y percentage, as they get multiplied, then definitely R will also get modified by some percentage, isn't it? So we can relate the values of X, Y and Z as Z equals to X plus Y plus XY upon 100. If the modification is an increase, it's a positive value. If the modification is a decrease, then it's a negative value. Nothing more than that. So let's learn the concept with some examples. The concept goes like this. If the length of a rectangle increases by 20% and the breadth decreases by 10%, then find the overall change in the area. Now in the problem it is clear that the length got increased. So the value of X is plus 20 and the breadth got decreased, so the value of Y is negative 10, and you know that area is length into breadth, isn't it? So we observe that length into breadth is area, length increases by 20 plus 20, breadth decreases by 10, so Y is negative 10. Now put in the value of X and Y in the formula, that is X plus Y plus XY by 100, we get the value of Z, and the value of Z is found to be 8%. So it means that the area gets modified by 8%. If the price of a commodity increases by 25%, then find the reduction in consumption so that the expenditure remains the same. So as not to increase the expenditure, that tells that the expenditure should remain same as before. Now we know that the cost into consumption is expenditure. He gave us that the price increases by 25%, and he mentioned that the final expenditure should not change, so the expenditure is zero. Now we know that when the price gets increased and the expenditure should not change, it means that we should decrease the consumption. So an increase in X should have a proportionate decrease in Y to maintain the same Z, isn't it? So plug in the values of X and Z in the equation and you get the answer of Y. So 0 is 25 minus Y minus 25 by 100, and we solve the value of Y. The value of Y is found to be 20%. So it is clear that an increase of 25 is balanced by a decrease of 20%, so that the final expenditure remains the same. Is that clear to you all? Now let us do the same problem with an alternate approach. The story goes like this. Let us see the same problem solving with an alternate approach. So we have learned that an increase in expenditure should be balanced by a decrease in consumption, isn't it? So that decrease in consumption is given by the formula X by 100 plus X. If there is an increase of price, to balance that increase of price, we should have a decrease of consumption, that is X by 100 plus X. So putting in the value of X as 25, 25 upon 100 plus 25 times 100 is 20%. Is that fine? So you can have many formulae in percentages, but please do not learn formulae, because formulas can be applied to only few cases. I'll give you an example where this formula will not work. The price of a commodity increases by 25. Now find the reduction of consumption so that the increase of expenditure is only 10%. Now in this case again, we know that price into consumption is expenditure. He gave us that price is increased by 25, so it is X is plus 25, and expenditure is increasing by 10, so given as Z is 10. So plug in X as 25 and Z as 10 to find Y. As you find that the Z value is 10, which is not 25, it means that there should be some decrease in consumption. So consumption should be negative, isn't it? So what do you observe? To make this happen, Y should be negative. So plug in the value of X and Z in the formula and solve for Y, and you get the value of Y to be 12%. So here you cannot apply the formula X by 100 plus X into 100, isn't it? So formula can be applied only in few cases. So keep in mind, please learn the concepts and not the formula. Is it fine? So this is how we solve problems of the model P into Q is equal to R. X percentage of a quantity, the initial value, is taken by A, Y percent of the remaining balance is taken by B, and Z percent of the remaining is taken by C. We have initial value. From initial value, X percent is taken to A. Once this X percent is removed, we have some balance. So from that balance, some Y percentage is taken by B, and we have something remaining. Now from the remaining, some quantity is taken by C, and after this X, Y and Z is removed, we get some final value. So if that final value is P, so the relation between P, X, Y and Z with the initial value is given by the formula as shown to you all. So we learn the concept of the relation between X, Y and Z by a small example. So Ravi pays 25% of his salary as rent. Ravi got some salary. From his salary, he paid some rent as 25%. Now, whatever remains, from the remaining, Ravi paid 20% of the groceries, right? And 40% of the remaining is meant for savings. So, his salary, from his salary, 25% is paid as rent. From the remaining, 20% is paid as grocery. Now, from the remaining, 40% are savings. Now, if he is left out with rupees 9,000, then find his salary. So it is similar to X, Y, Z and P, right? So plug in the values of P, X, Y and Z to get the value of salary. And the value of salary is approximately 25,000 rupees. So if you do it normally, it takes a lot of time. So just plug in the values to get the answers. So this is how we try to relate the initial value, the final value, and the change of percentages. In the previous case, we have seen if X percentage is removed, Y percentage is removed. Now, if you are adding the values, so assume that if X percent of a quantity is added to the initial value by A, and we get some value. On that value, if we add some other percentage called as Y percentage by B, and whatever we get on that, if we add Z percentage by C, then if P is the final value, then what is the relation between the initial value, final value, X, Y, Z? So we get it as initial value is P times 100 times 100 times 100 by 100 plus X times 100 plus Y times 100 plus Z. In the previous model, we have seen 100 minus X, 100 minus Y, 100 minus Z, because there we were reducing the terms. Here we are adding the terms. So keep that in mind. So a reduction is decrease and addition is increase plus value. So let us see a small example on this model. So the problem says Ravi got 25% increase in his salary, and a 20% of the increased salary is given as bonus. Please, second line is important. 20% of the increased salary is given as bonus, and 15% of the final increased value is given as conveyance. Now, if his final take home is rupees 90,000 rupees, is rupees 90,000, then find the initial approximate salary. So you are given X, you are given Y, you are given Z, you are given the value of P, and it is found to be approximately 52,000 rupees. Just plug in the values to get the outputs. Play with that. So please see the concept 7 where we have decrease in terms, where we have increase in terms. The formula remains the same with a small deviation where decrease refers to a negative value and increase refers to a positive value. Nothing more than that. Play with these things. So going ahead, in this concept, what do you learn? We learn that if the present population of a city is PP, I call it as present population, and this population in the city increases constantly per annum by some X percentage or by some R percentage. So after n years, if the final population is FP, then what is the relation between the initial population, final population, rate of increase or decrease, or n? So we write it as Fp is equals to Pp into 1 plus R by 100 whole power n. If it increases every year constantly, then we say it as plus R. If it decreases every year constantly, then we say it as minus R. The value of R is positive if it is increasing, and if it is negative, if it is decreasing, it is negative. So plug in the value as Fp is equals to Pp times 1 plus R by 100 whole power n. This is similar to your compound interest, right? The same story where we have an initial sum and that sum is compounded every year the rate of r percentage per annum. Play with that, similar to that. So FP is PP times 1 plus r by 100 whole power n. Now, and if you want to calculate the initial population n years ago, we simply calculate it by saying initial population as PP is FP upon 1 plus r by 100 whole power n. So once you have final population, initial population, r, n, out of 4 terms, 3 terms will be given to you. Plug in the values to get the 4th term. As simple as it. Okay. In this concept, we will be learning about the pass mark, the fail marks, the initial value to be passed, and the pass percentage. So we will be writing the relation between all these things. The maximum marks is given by y plus z on x times 100, where x indicates the pass percent of maximum marks, and you find y and z on the screen. It is as simple as it. So we'll see example on it, do not worry. And a little improvisation of this concept is given by a candidate scores x% marks in an examination and he fails by a marks. He scores x, fails by a, and he scores y percentage is b marks more than the required pass mark. So please keep it in mind. Person got x percentage, he fails by a marks. It means that he got less by a. And case 2, he got y percentage and he got b marks more than the pass marks. Now find the maximum marks. The maximum marks is given by a plus b upon y minus z into 100. You can do this normally, correlate them, get the output, but I gave you the direct formula. So let us see a small example of this part. So a candidate who gets 20% of the maximum marks in examination fails by 30 marks. So the pass marks is P. If this fellow scores 20%, he is less by 30 marks. And another candidate who gets 34% of marks gets 54 marks more than the pass mark. So 34% of the maximum marks indicates that it is P plus 34. Now question is find the maximum marks. So we can solve it in this way. If P is the pass mark, now case 1 says 20% of maximum marks is P minus 30. Case 2 is 34% of maximum marks is P plus 54. The regular way of solving it. Now we correlate the problems. We handle them by subtracting them, and you get the maximum value as 14% of marks is 84. The maximum marks would be 600. This is the general conventional approach of solving it. Yes, but as we have learned a formula, plug in these values in the formula, get the answer directly. It goes like this. Like what is given to us? You are given a, b, y and x. So plug in the values of a, b, y and x, and the answer is found to be 600. You can learn the formula or you can even learn the conventional approach of solving it. I'm giving you both so that you'll have clarity. You need not always learn formula. That's for now in this video. We have seen some models. We'll see how to apply all the models in the problems in the upcoming videos. So put your thoughts in the comment section and I will be ready to share my thoughts. So do not forget to like, share and subscribe. Thank you.